Yo, what's up, everyone? Welcome to Oxidation Reduction Part 2. Today we're going to talk about cell potential, and we're also going to start to introduce the electrolytic cell. So remember our diagram of a galvanic cell. And the thing about a galvanic cell is that the flow of electrons in a galvanic cell is spontaneous. Why is that the case? Why do electrons flow from the anode to the cathode so seamlessly? Well, really, the pull that the cathode has on electrons is greater than the pull the anode has. So you can think of the anode and a cathode in this tug of war when it comes to electrons. And when the cathode has a greater pull for electrons than the anode, you have a spontaneous reaction. When the cathode has more power than the anode per se, you have a galvanic cell. And the way we quantify this pull here is by using cell potential. And cell potentials are given in the form of half equations. And so the half equations that we care about here are going to be these. And you'll notice that these half equations are always reduction half reactions, and that's just how they are. But you can use these values even if you have an oxidation half reaction here. And by the way, these cell potentials are in their standard states, and you can tell that because you have that little degree sign on top of the E. And so these are in their standard states. But how do you calculate the cell potential of the entire cell, not just the half reactions? So the cell potential of this particular cell is the cathode minus the anode, and so it's going to be the 0.34 minus negative 0.74. So our cell potential of the entire cell comes out to 1.08. And so what does this 1.08 value really mean? Well, first of all, we have a big graph of just a bunch of half reactions and their cell potential values that you can use for determining the cell potential of a certain galvanic cell. But essentially, if your E cell, the cell potential of your cell is positive, then that reaction is going to be spontaneous, and you have a galvanic slash voltaic cell. On the other hand, if your E cell is negative, then you have a non-spontaneous reaction happening in an electrolytic cell. Remember, all of this is in standard conditions. All the cell potential values that we've talked about, the cell potential values of the half reactions, the cell potential of the entire cell, these are all standard conditions. So at 1 molar, 1 atmosphere, and 25 degrees Celsius. We'll see how to find cell potential values at non-standard conditions later, but for now, this is just at standard conditions. All right, let's do some practice. So what is the delta E cell potential that just represents the cell potential for this reaction where 2 Ag solid plus copper aqueous plus 2 chloride ions are reacting to produce 2 AgCl and copper solid? Well, let's write down the reaction here. So 2 Ag solid plus copper 2 plus 2 Cl minus aqueous is producing 2 AgCl solid plus copper solid. Now we see that our half reactions involve the silver and the copper, but we need to figure out which one's getting oxidized and which one's getting reduced so we can find out which one's the anode and which one is the cathode. So let's start with the oxidation numbers here. The oxidation number of silver starts off at 0 since it's just in its solid form, but it goes to +1 here at the end. And that's because the chloride has a charge of -1, so in order to balance that charge, the silver must have a charge of +1. And you see that the silver has gained charge. So what's happened is that the silver has become oxidized. And does the anode or the cathode do oxidation? Well, remember the anode does oxidation. And so this is the anode. So by default, this is the cathode. Remember, our E cell is just the E cathode minus the E anode. So that's just going to be 0.337 minus 0.222, which is 0.115. And that's answer choice D. You'll notice that even though the electrons don't balance up here, we use the half reaction as is, and we use the cell potential values as is, even though the electrons are not necessarily balanced. And so cathode minus anode, we get 0.115, and that is the right answer. Let's do one more. So which reactions are spontaneous under standard conditions? And we have two equations here. Let's go through each one of these on its own. So let's start with one. Two copper ions, which are aqueous, uh, react with CO to produce CO2 plus ions, and two copper solid. So which ones are getting oxidized, which ones are getting reduced? Well, the copper here starts off with an oxidation value of +1, but it ends off with a oxidation value of 0. So what's happened is that it's gotten reduced, and therefore the copper is going to be reduced in the cathode. And so the half reaction that we're caring about here is this one. This is the value for the cathode, and the other half reaction that we want is the one with the CO, and so this one is going to be the anode. That's the cathode, and that's the anode. So E cell is cathode minus anode, so 0.52 minus 0.28, and that's going to create what, 0.80? And since that's positive, we know that that reaction is going to be spontaneous. So 1 definitely checks out. 1 is going to be a spontaneous reaction, but we also have to check 2. 2 is going to be a very similar process, so 3CO2 plus aqueous and 2In solid produces 2In3 plus 3 copper CO solid. So let's look at the cobalt here. The cobalt starts off with a charge of +2, but it ends off with a charge of 0. So the cobalt in this case is the one getting reduced. And remember, reduction happens in the cathode, so this value right here is going to be the cathode value. And the other half reaction that we're caring about here is this one, and so by default that one has to be the anode. E cell is cathode minus anode, so negative 0.28 minus negative 0.34, and that I think is 0.06. But since that E cell value is positive, we know that it's going to be spontaneous under standard conditions. And so both 1 and 2 are going to check out, and therefore the answer that we want here is going to be C. So both 1 and 2, and that is the right answer. So really the magic of all this is knowing which one is the oxidation or reduction, and then using that information to figure out which one is the cathode and which one's the anode, and then just do the cathode minus anode calculation to see if you have a positive value or a negative value. Remember, positive values are spontaneous and they are galvanic, but negative values are non-spontaneous and they happen in electrolytic cells. Alright, that's all I have for this lesson. I hope you learned something, and I hope to see you for part 3. Thank you for watching.